Bose AR, Bose Augmented Reality. So I'm Dan Zeitman. I'm a senior developer advocate with Bose. There's some ways to get a hold of me. We're listening to music on a Bose speaker. Just happens to be. But I thought I'd start it off with a little demo of, there's going to be actually several demos. And I'm going to teach you today about learning the basics of Bose AR and designing wearables, designing AR for wearables. Now watch what happens when I walk around. Do you hear the difference as I turn around? It goes from one side to the left. This is spatial audio. So the way that happened was through the fact that there is a sensor pack inside these. Besides being headphones, surprise, surprise, there's sensors in here. And that allows for some really interesting things. So what is Bose AR? Well, it's not this. Right? It's not that. Nor is it this. It's being heads up and hands free. And as I mentioned, it's comprised of three parts: products, a toolkit, and then you guys, the creators and the developers. So the first line of products, surprise, surprise, fashionable sunglasses. Woo. So what you see here is Bose AR frames, and inside here are a speaker array, tiny little speakers on either side. It's not bone conduction, it's just simply speakers. And I said before, there's a gyroscope, an accelerometer, and a magnetometer in it. In addition to these cool sunglasses, we also have, about a month and a half ago, released a firmware update to all the QC35s out there. So some of you, if you bought it around November or December, have AR capability in your Bose product already. Moving forward, we're going to be shipping to over 1 million devices this year. So why is that important to you as a developer? Well, pretty simply, this is a new opportunity for working with a small, inexpensive device. These run about $200. That is already in the hands of consumers right now. We're actually almost at that number today because we released the update. We have other products coming down the line, but this is really exciting. So as an opportunity for a developer, this is ground zero. We have a toolkit enabling you to be able to harness the sensor data. And we're actually doing it in two ways. We have an SDK as well as a creator tool for non-technical folks to be able to harness the power of Bose AR. So the Bose AR SDK, as I mentioned, it works with the sensors. The sensors of this connect to my smartphone via Bluetooth. Simply put, you make a Bluetooth connection, you can make phone calls, you can grab the sensor data, and it goes to and from your mobile app. We support iOS, Android, and Unity right now. So as data scientists and people interested in machine learning and AI, this is the key thing about this product. The data that comes off of there is very simple to use and access. We have data from the accelerometer, the gyroscope, and a magnetometer. And using the magnetometer along with the GPS information in your phone, since it's connected to the smartphone, enables you to do some really fun, interesting experiences. At the end of the day, it's just time series data. Because we have those sensor packages, we're able to do something with the data. And what we've done is, using AI, we've been able to develop a series of gestures. So you can put the frames on and do a double tap. You can nod and shake. And you can get your movement, so as you're walking or running, so let's look at a quick demo. I have my frames, and this is the typical procedure is to make a connection. Our SDK allows you to do that connection. It gives you this UI that you see there. And then the challenge in a room full of Bluetooth is to find the frames. And as you see, as I move that around, we're getting the raw data off of this. So I took our basic example, which comes with the SDK, and I added it a little modification. And now I'm going to record some data. They do make prescription lenses for the frames as well. I just haven't ordered mine yet. But I'm going to have some fun. So I'm going to hit record. I'm going to run. Yeah, I know. Fun, right? Morning exercise. I'm going to walk. And I'm going to attempt to dance. Right? Okay, so you get the idea. I'm recording there, and now I'm going to stop. And what I've done, so many people in the room. Set that down. Find my laptop. Y'all see that? So as simple as doing a share sheet. You have the ability to transfer some data. In this case, I've created a CSV. Let's take a look. So we now have time series data, lots of it. So what can we do with that? Well, let's visualize it. Who all's worked with Jupyter notebooks? Ah, lots of people, right? So I created a really simple Jupyter notebook here. Does this look familiar to you guys? So what do we got? We're using pandas and NumPy. And here, I'm going to read some sensor data in. And then create a little visualization of all of that. So here we've got, this is something I did previously, but you can see very simply we're able to get the data off, and now we can take a look at it. And we can look at all the different bits. You know, the nice thing about these notebooks is it's really easy to do things like hit describe, for instance, and then all of a sudden, so I've taken the attitude, which is the pitch, roll, and yaw. So pitch is up and down, roll, and yaw. I'm able to do really quickly hit a describe and then get to see the mean, the minimum, 75%, max, etc. So it's pretty cool. It's super easy to take a quick look at what it looks like. So let's look at my data that I did just before. I think I said, there's a demo summit. Demos, sensor data summit. So summit. And pray that it runs. There we go. So the first step in all this is to kind of get an idea of what's actually happening. And you can see as I'm running around, it kind of changes. So I'm not a data scientist. I'm an iOS developer and an audio AR developer. But the challenge for you is to take a device like this, very inexpensive, and then start thinking about potential use cases for the data. What sort of things could you do with it? You can build your own gesture recognizers, number one. Using Core ML, you can come up with your version of a gesture. So that might be, I don't know has anybody followed the latest thing about dancers wanting their work to be recognized? Or not. Yeah, so exactly, right? Some very famous people have been ripped off and their work's been used in games, and now there's legal suits to that. So potentially you could motion capture what people are doing dancing with this device. You don't need a big camera system, a lot of dots on your face and all that. This is enough to capture unique movements, and you can start copywriting your moves if you're so inclined. As I mentioned, what we're really doing is human activity recognition. And some hints on what you can do. You can use long-term, short-term memory to process it. You can build a DNN or use generative adversarial networks to do that. Again, I'm not a data scientist, but I can tell you that there's lots of great work out there of people already doing this. And Towards Data Science, which is a Medium blog, has a couple of really, really awesome articles on it. The first one is Human Activity Recognition Tutorial, Keras and Core ML. You can basically build your Jupyter notebook and then eventually export it to Core ML, put it on your iOS app, and build your own recognizers. And then there's a 4-part series, Run or Walk, Detecting Motion, Activity, and Machine Learning with Core ML. So both of them give you an actionable way and an actionable path to be able to get there. So let's talk about what could you do with gesture recognizers and the frames and all of that. And there's 6 different design patterns that seem to be really popular with our developers. So audio pinning, it's this idea of creating a layer of audio around you. In that first demo that I did, I had set it up so that the audio was coming from one point, centered by the position of your frames. And as you turned your head to the left or the right, the sound moved around you. It sounds amazing on the QC35s and on the frames. It's a little harder to represent spatial audio in a room, but imagine sound just everywhere around you. And that's what scene's about. That's the scene pattern, where you just build this environment of audio around you. The spotlight is a really interesting one because this pattern you can use like a dashboard even. You have the ability to do a double tap gesture, for instance. So you can position audio around you and then use the gestures. Shadow, audio responds to your movement, so as you're moving through an area, maybe you come across the sound and the sound follows you. Joystick, you might want to augment the experience with using a your physical device as a controller. And then the other thing to remember is there's a microphone on the frames, so you're able to capture audio as well and do voice commands. So just real briefly, let's talk about the various patterns. Gaming is one. Use case is gaming. We have 3 apps in the App Store right now on iOS, and I wanted to do another demo of AirPlay. And AirPlay is a really fun app. It's a story, and it uses voice commands, gestures, and custom gestures that they used AI to build. So I am going to try to make this work. Resume.
You will need to trust me. Are you alone? You will need to trust me. Are you alone?
So I shake my head no.
It's okay. Be careful. They're not who you think they are. You need to know that nasty space aliens are out there, and they won't walk anywhere on your head. The jack and audio channels are on the globe to try to find you. There's lying, no talking. I'll ask simple questions. You can nod or shake your head after the transmit tone. Next thing, are you indoors?
Yes.
Easier to spot. Don't look up at the sky.
Or duck? Which one?
360 duck. Either way, get ready. 360 turn or duck. Now. Either way, get ready. 360 turn or duck. Now. It worked. We zeroed 4 of those suckers. We have scanned you as well. We can work that out. But turn the other direction. Tilt your head to the right this time. Turn the other direction. Tilt your head to the right this time. I didn't read it correct. Try the right side.
So part of this experience
Communication is not what it seems.
So part of this experience is actually calibrating. We're actually calibrating the experience as that, rather than at the beginning there's that initial calibration of the device. But as you're working through the game, I'll go ahead and stop that. As you're working through the game, you can actually recalibrate along the way. So what they were doing was they were making sure that during certain parts of the game, they were making sure that the user's still attentive and still working through it. And also, there's just natural drift with any accelerometer. So a good way to kind of combat that is through your storyline, come up with fun, interesting ways to recalibrate. So that was AirPlay. Another pattern we have is travel. And we have 3 apps in the App Store now called AutoCast, Walk, and Naviguide AR. And the way this works is it uses your GPS location. So it's using the pattern of using the phone's GPS and the directionality. And that's what's different. With Bose AR, you have directionality in which a person's working. So we already have the heading, we have the GPS location, and then if I'm looking this way or this way, it's an additional piece of context. And this is huge, because if you think about your current experience with your mapping app is you're walking around and they've done a really good job of figuring out how to count your steps with core motion and some other technologies, but it doesn't know which way you're looking and doesn't know where your attention is focused. And that's what's really cool about having this additional information. So now you can literally walk down the street and look at a restaurant and get the information about that restaurant with a program like Navigator, for instance. So I want to bring up my friend Randy Fong. He's a developer. I started about 6-7 weeks ago at Bose AR, and I called him up and I said, hey, I'm working this cool new job. He's an iOS developer I've known for many years. We met at hackathons and meetups and long bits, and I want to introduce Randy. He's actually created an app in the App Store. It's called Unicorn Tour. I'll let him tell you all about that, and he's going to demo a feature that he's been building on Bose AR. So this is Randy Fong.
Hi everyone, how's it going? Great. Yeah, so actually, a little background myself. I'm an iOS developer. I came from the enterprise world. I have an app out there called Unicorn Tour. It's on iTunes. You can download it. It turns San Francisco into a living tech museum. What I wanted to do, there's a feature in there that's an AR feature, a visual AR, where you go to the visitor center up in Moscone Center. It has this map, and when you go up there, you can do some AR stuff. And I went to add some stuff using the Bose for Institute, audio AR. And so what I'm going to do is I'm going to demonstrate that.
So Randy is using a couple of APIs from Apple, the speech to text, text to speech, part of the core frameworks that are now available on that platform.
So when you go into the visitor center, you see this map on the wall, and it has the neighborhoods of San Francisco. So I have the visual AR that's built in my app. But what I'm going to be doing, which I'll show in this demo, is add the audio AR using the Bose frames. So for instance, in this instance, I'm just going to press start. I don't know if it's going to work. We'll see.
Make sure you lock it up. Make sure you use the speaker.
Okay.
Sorry, but a narration does not exist for OK.
So just hold it.
Chinatown? Chinatown?
Built near Portsmouth Square.
Historic part of San Francisco. Chinatown is the oldest and one of the largest in the United States. The entrance to Chinatown at Grant Avenue and Bush Street is called the Dragon's Gate.
So what I did was...
Sorry, but a narration does not exist.
Stop! Anyway, what I did was I built into this, using this, my own little Siri, really. So for each one of the neighborhoods, I label each one with commands. The speech recognizes the commands like the other demos you've seen here, but within Swift. And then it pulls out the narration that I want, and it goes to the synthesizer. So we can do another one, North Beach.
North Beach, rich in Italian heritage, compresses cabarets, jazz clubs, galleries, inns, family-style restaurants and gelato parlors into less than a square mile.
So the idea is that when people go to the map, or maybe they're in a neighborhood, if they want the narration, they just, they're going to walk around with these things, which is a little better than just having your earphones in there, because you don't want just dorky, and it's pretty sensitive as far as the speaker, as far as the microphone, and the speakers are really awesome. If you have a chance to do it, the fidelity is really good. It's actually surprised me how good it was.
Yeah, thank you, Randy. So that was Unicorn Tour. One of our first Bay Area Bose AR developers, and I'm going to wrap this up really quick, just zipping through towards the end. Ultimately, you need to think about which ideas are going to have the biggest impact when you're designing for experiences for Bose AR. What things excite you? What's most unique to the experience? And then think about the fact that this is data and stuff that you can work with. So I just want to go all the way to the end. What are the next steps? Well, you can sign up for Bose AR and become one of our developers at developer.bose.com/Bose-AR. We have a GitHub that we're just launching, github.com/BoseDevs. There'll be a sample for this data recorder plus a Jupyter notebook to get you started coming up next week. And then join us on meetup.com to come to our events that we're going to do. So again, I want to thank you all for taking the time and bearing with the technical difficulties. We hope you get a chance to really play around with the platform. It's a really fun and exciting platform. And come see me later if you want to actually hear what these sound like. You'll be blown away. Thank you.